Let us solve one problem from JEST Physics 2024 paper. The problem states that a classical particle undergoes simple harmonic motion is confined to the region a minus a and a on the x-axis. If a snapshot of the particle is taken at a random instant of time, what is the probability that it would be found in the region of a by 2 comma a? So we need to find this probability of finding that particle in the location a by 2 and a, right? So we use the probability distribution for simple harmonic motion. In a classical simple harmonic motion, the particle spends more time near the turning points because its speed is lowest there, right? Hence the probability density px is inversely proportional to the velocity at that point. So we can so for a particle and SHM, so for a particle in simple harmonic motion, we can write xt equal to a cos omega t. The velocity as a function of the position, we can write the velocity as a function of position. We can write Vx equal to omega into root over a square minus x square. So the probability density is density, we can write px is proportional to 1 minus v by x equal to root over a square minus x square, right? So we normalize over plus a to minus a, will normalize this over minus a to plus a, so it will we will have px equal to 1 by pi into root over a square minus x square for epsilon x belongs to minus a to plus a, right? We will compute the probability in the region of a by 2 and a, that is we will compute the probability in region a by 2 to a. We have p equal to a by 2 to a into 1 by pi, similar a square minus x square into dx. We'll have a substitution of this value, so we'll substitute, let x equal to a sin theta, then dx equal to a cos theta d theta, right? When x equal to a by 2, then sin theta is equal to half, or theta is equal to pi by 6, so 30 degree. right? So when x equal to a, so when x equal to a, so it is sin theta equal to 1, so pi equal to 90 degree, pi by 2. So we'll have this limit from pi by 6 to pi by 2. We have 1 by pi into root over a square minus a square sin square theta into a cos theta d theta. So we'll have p equal to pi by 6 to pi by 2 into a cos theta by pi a cos theta d theta. So it will be 0 pi by 6 to pi by 2 so it will 1 by pi, so it will have 1 by pi by 2 minus pi by 6, so it will be 1 by 3, right? So 1 by 3 is our required probability of the particle for found in the region of a by 2 and a. So it matches with the option A of the given problem. Hope the solution is clear. So thanks a lot.